Swayam Prabha. Digital India. Educated India.
In this lesson, we will look at an important property of resistive networks, which is known as reciprocity. Okay. Now, let us go back to the examples for which we evaluated all four two-port parameters. Okay. So, one of the circuits we evaluated for is this very simple circuit. Okay. Just have two resistors of 1 kilo ohm each, and these were the parameter sets. Okay. This is the Y matrix, Z matrix, H matrix and G matrix. Okay. Now, the interesting thing here which you may have noticed is that the off diagonal elements, okay, that is Y12 and Y21 are equal to each other. Similarly, Z12 and Z21 are equal to each other. And if you look at the other two parameters, H12 is not equal to H21, but H12 is exactly minus H21. Similarly, G12 is exactly minus G21. Okay. Z12 is Z21, Y12 is Y21, H12 is minus H21 and G12 is minus G21. Okay. So, there appears to be some relationship between the parameter 1 2 and parameter 2 1, that is between the transmission from port 1 to port 2 and from port 2 to port 1. Okay. So, now the question is this just a coincidence? Of course, there is no such relationship for Z11 and Z22. Okay. They can be arbitrary. Here also they are quite different from each other. Now, this relationship between parameter 1 2 and 2 1, is it a coincidence or is it some special property of networks? Okay. Now, to be sure, we have also seen networks for which the property which I just now mentioned does not hold true. Okay. For instance, this is another circuit, and in this case certainly Y11 is not equal to Y12, okay, and Z11 is not equal to Z12 and so on. Okay. So, they have some numbers which are not necessarily equal to each other. Okay. So, there does not appear to be a special relationship between the forward and the reverse parameters in this case. Now, as part of activities or assignments, you would have solved for the two port parameters of other networks which consist of only resistors. Okay. The difference between this network and the other one which we looked at is that this circuit includes control sources, whereas this one does not. So, now the question is this a coincidence or is this some special property of resistive networks? It turns out that all resistive networks have this property. Okay. You would have noticed this not only from this one, but also from other problems which we have solved. Okay. And it turns out this is known as reciprocity, that is, if you have a purely resistive two port network, then the forward transmission and reverse transmission are closely related. Okay. If you describe them in terms of Y or Z parameters, they are equal to each other, and in G or H parameters, they are the negative of each other. Okay. So, later in this unit, we will go on to prove the reciprocity theorem. So, now I am just stating it. Okay. Now, here I have tabulated the relationship between different parameter sets. Okay. So, I have listed parameter 1 1, 1 2, 2 1 and 2 2, and I have taken Z parameters as my primary means of representation, and I have represented all other two port parameters in terms of Z parameters. Okay. For instance, if you look at Y11, this you can do by inverting the 2 by 2 matrix. Y11 turns out to be Z22 by this delta Z, means the determinant of the Z parameter matrix. Similarly, Y12 turns out to be minus Z12 by delta Z, Y21 is minus Z21 by delta Z, and y22 is z11 by delta z. Now, the point is, you can clearly see that if z12 equals z21, right, then y12 will also be equal to y21. Now, it is not that a circuit is reciprocal in z parameters, but not in y parameters or other parameters. Okay. Similarly, these are the expressions for h parameters. Now, I will look at only h12 and h21. h12 is z12 by z22 and h21 is minus z21 by z22. So, clearly, if z12 happens to be equal to z21, then h12 will be minus h21. Okay. So, that is the reciprocity condition in terms of h parameters. Similarly, if you look at g parameters, g12 is minus z12 by z11 and g21 is z21 by z11. If z12 equals z21, then clearly g12 will be equal to minus g21. Okay. So, what I am trying to point out here is that reciprocity is a property of the network. It is not related to what parameters you choose to describe the network. Okay. So, reciprocity refers to some special relationship between a forward parameter and reverse parameter of a two-port network. Okay. And that holds good, that is reciprocity holds good regardless of which parameter set you choose to represent the two-port in. Okay. So, clearly from these relationships, z12 equal to z21 implies y12 equaling y21 or h12 being equal to minus h21 or g12 being equal to minus g21. Okay. Is this fine? And these turn out to be very useful relationships as well, because many times they give you a tremendous shortcut in solving for certain types of circuits for certain types of questions. Okay. Now, one more thing I want to point out is that again, let us say z12 happen to be 0, that is there is no reverse transmission in z parameters. Then that means that the reverse transmission parameter, regardless of which one you choose, y12, h12 and g12 will all be 0. Okay. And such a network where the reverse transmission parameter is 0 is known as a unilateral network. And similarly, if the forward parameter is 0 in z parameters, that is if z21 is 0, the forward parameter y21, h21 or g21 will also be 0. Okay. So, these properties being unilateral or being reciprocal are just a property of the network, and that will hold good regardless of which parameter set you choose to describe the network in. Okay. A reciprocal network, reciprocal two-port network means that the forward and reverse parameters are equal, and if you choose z and y parameters, or equal and opposite for g and h parameters. Okay. Now, a unilateral network this is when, let us say, either the forward parameter is 0. This means that there is a control from port 2 to port 1, but not from port 1 to port 2. Okay. Or the reverse parameter is 0, which means that there is control from port 1 to port 2 and not from port 2 to port 1. Of course, if both these are 0, if both the forward and reverse parameters are 0, that means that there is no communication between port 1 and port 2. You may as well have two separate circuits. Okay. two separate resistances, one connected to port 1 and one connected to port 2. Of course, this is not a very interesting two port network, because if there is no relationship between the two ports, you can simply treat the whole thing as two separate one port networks. Okay. So, the main thing I want to emphasize here is that there is some property called reciprocity and another one called being unilateral, and these are unrelated to which parameter set you choose. Whichever you choose, they should come out to be the same. And we notice that resistive networks have some special relationship between the forward and reverse parameters. They seem to be reciprocal. That is, the amount of forward transmission equals the amount of reverse transmission. Like I said, it is not just a coincidence due to the particular example we chose. It is a general property of resistive network, and we are going to prove that in the next lesson. Okay.